Question number 9. Suppose your school is in the midst of a flu epidemic. The probability that a randomly selected student has the flu is 0.35, and the probability that a student who has the flu also has a high fever is 0.9. But there are other illnesses making the rounds, and the probability that a student who doesn't have the flu does have a high fever as a result of some other ailment is 0.12. Suppose a student walks into the nurse's office with a high fever. What is the probability that she has the flu? Write your answer as a decimal, not a percent, around at 3 places. Normally, you wouldn't be given this drawn out tree diagram, but it's a good practice to make one for a problem like this. So what we start with is we got our person. That person's going to come in. They're either going to have the flu or not. We are given the probability of flu. That's 35%. So this is going to be 1 minus 0.35. So 65% of the people coming in don't have the flu, 35% do. Of those flus, we got 90% have fever, which means 10% have no fever. Of those no flus, we have 12% have a fever, which means 88%, 1 minus 0.112, have no fever. And that's all we're given. But the question says, suppose a student walks into the nurse's office with a high fever. So we are given fever. What is the probability that she has the flu? Given fever, what is probability of flu? Well, we know the probability of flu is 35%, but knowing that that person has a fever, because there are some people that have fevers, some of those people aren't going to have the flu. So first thing we want to do is we want to figure out, hey, what are going to be those probabilities? What are your ands? Okay, so what is flu and fever? Well, that's going to be 0.35 times 0.9. That's going to be 0.315. So I know people that have the flu and the fever combined, 31.5%. Now let's look at the other group. What's the probability of no flu, but still a fever? So the probability of no flu and fever, 0.65, 0.12. And that's 0.078, quite a bit smaller. But now we have combined the percent of people that have a fever. Okay, so I have the fevers with the flu people, I have the fevers with the non-flu people. So what we're going to do for given fever, this is probability of flu given fever is equal to the probability of flu and fever over the probability of just the fevers. So we always divide by the given. Well, the given is these two combined. Okay, these are all the fevers. So that's going to be the same, flu and fever, that's going to be 0.315. And we're going to divide that by the combined fever groups. So 0.315 plus 0.078. And that's 0.393. So this problem becomes 0.315 divided by 0.393. And that's 0.08 or 0.8015. How do I interpret this? You say, of the people that had a fever, approximately 80.15% had the flu. So of the people who had fever that walked into this clinic, you would say 80.15% had the flu. That's the interpretation of it. The answer is 0.8015.